So we've done a small review about angles and measuring them in degrees, and now we're going to talk about radians. So it's completely normal that before this class, you may not have heard about a radian measure before. You have only worked with angles and degrees, and it's fine. We're going to define it here, and then we're going to talk about how to convert from degrees to radians and radians to degrees. So what is a radian? So to define a radian, we take what is called a central angle. And I have a little diagram of a central angle. A central angle is an angle that the vertex is in the center of the circle, hence the word central. Now, a circle has what is called a radius. The radius is the distance from the center to any edge of the circle. It's always the same. So this is called the radius, and we denote it by the letter R. Now, the angle, which in this case is theta, subtends an arc length. And the arc length is the outside part of the circle that it encompasses. So it's part of the circumference. So this little purple part here is called the arc length. So the bigger the angle, the bigger the arc length. The smaller the angle, the smaller the arc length. And we denote this by the letter S. Don't ask me why it's not A, it's S. So we have that to define a radian, if the purple part is exactly the same as the black part, so if R is equal to S, then the angle is exactly 1 radian. So that's how 1 radian was defined. So from this, we introduce what is called the arc length formula. And the arc length formula is really straightforward. The arc length is equal to the radius times the angle. And you can see that if theta was 1, then S was equal to R. Now, there's a really tricky part about this angle that is probably the only mistake I really see when people are using this formula, so you have to remember this, is that the angle has to be in radians, because this is how the formula was introduced. So really try to remember that about the arc length formula. It's a very simple formula, but you have to remember that the angle has to be in radians. You cannot plug in degrees. So how are we going to switch back between degrees and radians? And we're going to use the arc length formula, and we're going to use the formula of the circumference of a circle. So we want to remember from before, that the previous video, that if we do a full circle, this is 360 degrees. And I'm going counterclockwise, so it's a positive 360. And we can call again the angle theta. So a full circle is equal to 360 degrees. Now, if I take the arc length that this angle subtends, it is the entire circle. I would start here, and I would go around the entire circle. Until I got back to the beginning, because that's 360 degrees. So my arc length is the full circle, the outside of the circle. And so the entire outside of the circle is also called the circumference. And this only happens again if the angle is 360 degrees. So my angle has done 360, my arc length is the circumference. This is the biggest arc length you can have. But I have a formula for each of these. So the arc length formula is S is equal to R theta. And the circumference formula, if you forgot it, it's okay, C is equal to 2 pi R. But these are the same, so I can set them equal to each other. So I have R theta is equal to 2 pi R, which means that I can cancel the R's because there's 1 on both sides. So theta is equal to 2 pi. But remember what we talked about, the arc length formula, the theta has to be in radians. And here is the super important part. This is what comes out of it. This is really what we want to remember, that 360 degrees is equal to 2 pi radians. Now, if you don't have a degree symbol, it is assumed to be radians. So you don't have to keep writing radians, thankfully, because that would really take a long time. So it is okay not to write radians. If you don't have a degree symbol, then you just write the 2 pi, it's okay. So how do we convert back and forth? So you can either divide on either side. I'm going to make a little bit more room here. So we're going to create a conversion formula for each. And so we're going to have the first one is going to be, so if I divide both sides by 360, so if I have 360 is equal to 2 pi over, I divide by 360, then I get that 1 degree is equal to pi over 160. So anytime you want to go from degrees to radians, you multiply the degree by pi over 180. I'm going to put this to the test in the problem. Or you could take 360 degrees and divide it by 2 pi, and it can divide by 2 pi. And that's going to give me 180 degrees over pi is equal to 1 radian. So anytime I want to go from radian to degrees, I multiply by 180 over pi. So we're going to do the opposite. Pi over 180 from degrees to radians. So this will take us degrees to radians. And this will take us from radians to degrees. Okay, let's put it to the test. So we want to convert each. So we have, actually, let me highlight this here. So we have 120 degrees. Okay, so we have 120 degrees. We want to change it to radians. So we're going to multiply by pi over 180. So here the zeros are going to cancel. 12 and 18 both share a common factor of 6. So I can cancel a 6 from 12, which will leave me with a 2, and a 6 from 18, which will leave me with a 3. So I get 2 pi over 3. So 120 degrees is 2 pi over 3, exactly. Okay, let's do another one, negative 45. So I get negative 45. I can drop the degree symbol because I'm changing it to radians. Now here you might not see right away because 45 ends up going into 180. But if you didn't see that, you could start off with just seeing that maybe 5 goes into 180 and 45, if that was okay. So you can take away a 5 from 45, which will leave you with a 9, and 5 goes into 180 36 times. So you get negative 9 pi over 36, but 9 goes into 36 4 times, so this is negative pi over 4. Now, you are going to be working with 45 degrees a lot, so you're going to see this more commonly, and you're going to be able to recognize that negative 45 degrees is pi over 4. But 45 plus 45 is 90, and 90 times 2 is 180, which is why it goes in 4 times. So here are my degrees to radians. So let's now go radians to degrees. So I have to use the formula the other direction. So I have 7 pi over 6 times now 180 degrees over pi. The pi's cancel. 6 goes into 180 30 times because 6 goes into 18 3 times. So this is 210 degrees. And remember, you have to have the degree symbol because we're converting it to degrees. Let's do one more. I have negative pi over 2 times 180 degrees over pi. Again, the pi's cancel. And 2 perfectly goes into 180 90 times. Yes, so negative 90 degrees. Now, one thing I want to make a note of here is that you have to keep the sign the same, right? Because remember that whether you're positive or negative just means that you're going counterclockwise or clockwise. And that's going to happen whether you're in degrees or radians. So the negative or the positive has to come with you. That's not going to change. So let's use the arc length formula. Let's do one more problem. Given a circle of radius 5 feet, find the arc length subtended by the angle of 60 degrees. So I'm looking for the arc length, so I know I'm going to have to use the arc length formula. But this has to be in radians. So I know that r is 5, and I know that the angle is 60 degrees, but I cannot use 60 degrees in the formula. So I'm going to have to convert it. So I do 60 pi over 180. The zeros cancel. And again, 6 goes into 18 3 times. So I get pi over 3. So now I can use my formula. S is equal to 5 times pi over 3. So I get that my arc length is 5 pi over 3, and I am in feet. And here's my final answer. And I'm going to teach you a little trick on how to convert some of the angles we know the most in the next video.